Hello everyone, my name is Karthik pippalla, and today I am excited to share my solo project titled Text Extraction from Images using NLP with Google Cloud Vision API. This project is all about taking real-world visual data like receipt notes or documents and turning them into meaningful structured information using AI tools. What makes this interesting is that it's not just one technology, it's a smart combination of OCR or optical character recognition with NLP, which is natural language processing. Together, these two allow us to convert images into data, then analyze or organize the data into powerful ways. For the next few minutes, I will walk you through how the process works, why it matters, and where it can be applied. In our daily lives, we encounter tons of image-based text, photos of signs, handwritten notes, scanned documents, and even forms. Often, this kind of data is hard to process because it's not digital. You can't search it, analyze it, or automate anything unless it's converted into text. This is exactly the problem. This is exactly the problem we have discussed. This project addresses. The first step is extracting the text from using OCR, and then we use NLP to make sense of it. For example, imagine taking a photo of a receipt. The system can extract the item name and prices, analyze sentiment from any customer notes, and then store the structured data automatically. That entire flow from image to insight is what I want to export to you. I choose this topic not only because it's technically fascinating, but also because it's incredibly practical. Businesses, hospitals, schools all generate and rely on visual data. Automating how we understand the data can save hours of manual work and even reduce errors. What is NLP? Now let's break down NLP. Natural language processing is a branch of AI that helps computer understand and work with human language. It sits with an intersection of linguistics and machine learning. Whenever you ask Alexa to play a song or Google to finish your sentence, that's NLP in action. In the context of this project, NLP comes in after OCR has done its job. Once we extract the text from an image, we might want to clean it or tokenize it, meaning split it into words or phrases, or even detect the sentiment like whether a review is positive or negative. NLP gives us the tool to make raw text meaningful. And there are many tasks within NLP: translation, text classification, keywords, extraction, summarization, and more. Think of it as it giving computer the ability to read and understand language like a human. And when paired with image-based OCR, it opens up new possibilities for automation. What is OCR? So what exactly is OCR? OCR stands for Optical Character Recognition. It's the process of detecting and converting text from scanned images or photos into machine-readable format. You probably used OCR without even knowing it. When you scan a document and it becomes searchable, that's OCR working behind the scenes. OCR has been around for decades, but with modern AI, it's become far more accurate. It can now read handwritten notes, different fonts, and even deal with noisy or blurred backgrounds. It's the bridge between physical documents and digital text. In our project, OCR is the first key step. We feed an image into the system, like a snapshot of a form or a page, and OCR pulls out all the text. This raw text can then go into NLP for deeper analysis. OCR is what makes text extraction possible, and without it, we wouldn't be able to do any of these processing that follows. To implement OCR in this project, I used a Google Cloud Vision API. This is a cloud-based service that provides a suite of image analysis tools, including label detection, facial recognition, object localization, and most importantly for us, text detection. One of the strengths of using Google Cloud's API is that it handles a lot of heavy lifting. It's trained on huge datasets, supports dozens of languages, and can even handle handwritten content and can even pull handwritten content. Plus, it returns not just the text but metadata, like where on the image the text was found. That's useful if you are building document parsers or structured data extractors. Another benefit is that it's very developer friendly. You can integrate using Python, Java, or even curl commands. The simplicity of the API combined with its power made it an ideal choice for this project. Text reduction feature in Vision API. The text reduction feature of Vision API is where OCR magical really happens. You send an image, let's say scanned invoice or a photo of a sign, and the API returns all the text it can find. It also gives you bounding text boxes showing exactly where in the image the text appeared. That's useful for structured documents like receipts or forms. The feature supports multiple languages, which is great if you are dealing with internal documents. It also recognizes printed and cursive handwriting, though handwriting tends to be more challenging. In my tests, I found that it worked really well on clean, resolution images. Even slightly blurred photos were processed accurately. This level of reliability is what makes the API great for production use, not just for demos, but real business applications. Architecture of the system. Let me walk you through the architecture of how the entire system works. Step 1. The user submits an image. This could be done through form, mobile app, or uploaded to a server. The image is sent to Google Vision API for text detection. Once the text is extracted, it gives pass to the NLP module. Step 2. Depending on the use case, this module might clean the text, tokenize it, extract words, or run sentiment analysis. Step 3. The processed data can be stored in database, shown to users, or even used to trigger actions like sorting files or flagging documents for reviews. This model this modular approach makes it easy to use, scale, debug, or improve individual parts without changing the whole system. For instance, we can upgrade the NLP logic independently from the OCR layer. Setting up Google Cloud Vision API. Setting up the Vision API is surprisingly easy, especially if you are familiar with Google Cloud platforms. First, you create a project in the Google Cloud console, then you enable the Vision API and create a service account to generate your API key. Next, you install the Python client library using with pip. After that, your code just needs to authenticate using your key, load the image, and send it to the API. Google provides excellent documentation, and it took me under 30 minutes to go from zero to getting results from the API. That's one of the reasons I recommended this tool. It lets you focus on the logic of a project, not on setup details. Code walkthrough, extracting text from the images. Here's a quick look at how the code works. First, you load the image file using standard Python tools. Then you pass the image to the Vision API's text detection method. The API responds with a structured results, usually a list of blocks, paragraphs, words, and their coordinates. You can then loop through these results to print or store the recognized text. What I really liked was that it is not only gives you raw text but organizes it logically, which makes parsing much easier. You can also apply filters like only extraction text from the certain region or only keeping results with high confidence scores. This flexibility makes it perfect for integrating into larger data pipelines. Applying NLP on extracted text. Once we have the text, we can start using NLP techniques to analyze it. Step 1 is usually cleaning, removing unnecessary white spaces, correcting encoding issues, and normalizing the case. Then comes tokenization, splitting the text into words or sentences. Depending on the application, we might do lemmatization or stemming, which reduces words to their base forms. After that, you can apply analysis like keyword extraction, name and data recognition, which is called NER, or sentiment analysis. For example, if the image was customer review, NLP could detect the tone and highlight the product names. If it was a medical form, you can might extract patient info symptoms. The power here is that we are turning raw unstructured text into data we can actually use. Challenges and limitations. Yes, every product has some challenges and their limitations. Let's talk about some real world challenges. One of the biggest is image quality. If the photo is too dark, blurry, or skewed, OCR accuracy drops. While the API is robust, it still struggles with purely tilted scans. Another challenge is handwriting. Printed text works great, but cursive or unusual handwriting can confuse the model. Multilingual documents can also be tricky, especially if languages are mixed within the same image. And finally, in NLP is always the risk of misinterpretation. Sarcasm, irony, or domain specific jargon can throw off the sentiment or keyword detection. So, while the system works well in many cases, it's not 100% perfect and needs testing and adaptation for specific domains. Benefits of using Google Cloud Vision plus NLP. Despite the challenges, the benefits of combining OCR and NLP are huge. You can automate hours of manual work, no more reading through documents and typing out data. It's good, right? This improves speeds, reduce human errors, and free up people to do higher value tasks. So scalable. Whether you're processing 10 documents or 10,000 documents, the cloud infrastructure can handle it. The system can work in real time or batch mode. Plus, the insights you can get from NLP like sentiment, keywords, or even topic modeling can help business make better decisions, spot trends, or personal customer interactions. So it's not just about getting the text, it's about making the text useful. Applications. There are countless applications for this technology. In retail, OCR plus NLP can automate expense tracking by scanning receipts. In healthcare, doctors' handwritten notes can be digitalized and analyzed for key medical terms. In finance, banks can process loan documents and IDs much more faster. Even in education, scanned homework or exams can be analyzed. In travel, OCR can extract passport or visa data. And in law enforcement, surveillance photos can be processed for license plates or signs. It's a versatile solution that's already been used in tools like Google Lenses, Adobe Scan, and enterprise automation platforms. Conclusion and key takeaways. To sum it up, this project shows how far we come in automation and understanding of visual data. Using Google Cloud Vision API, we can extract text from images with high accuracy. Then with natural processing, we can structure, analyze, and even derive insights from the text. The system is modular, scalable, and adaptable. Whether you're a small business scanning for forms or a large enterprise processing global, the setup has something to offer. The big takeaway: we are no longer limited by the format of our information.